Good morning, everybody. This is Mike Heumann from G2M Research, and thank you for joining us in the G2M Research multi-vendor webinar on implementing NVMe and NVMe over Fabric for cloud service providers. I'm going to give a quick introduction and kind of go through the ground rules of the webinar, and after that, we'll turn it over to our panelists. So we're going to have, at the beginning of this, after I go through and introduce the topic, we're going to have each of the panelists talk for about 8 to 10 minutes on their topic. And we'll go through some questions. We have 3 panel questions we'll be asking them. We also have 2 audience survey questions that you can fill in using your Zoom Q&A session window. Finally, we'll go to audience Q&A. And if you have Q&A, please submit it through the Zoom Q&A window. We'll hold all those answers till the end, but we're going to give a good 12 minutes to answer those, so it should be pretty straightforward. We're also recording this webinar, and we'll provide a recording to everybody that registered for the webinar. I'll probably go out tomorrow before close of business, as well as a PDF of the slide set. So with that, let me introduce our panelists. With us, we have Joel Dedrick. Joel is VP and General Manager at Kioxia. We also have Josh Goldenhar, who's VP of Product Marketing at Lightbits Labs. We have Mark Micklon, who is Director of Platform Partner Alliances at Western Digital. And myself, I'm Mike Heumann, the Managing Partner at G2M Research. So when we talk about cloud service providers, if you look at their storage, networking, compute options, today they've got a lot of different choices. If you think about what they do, they tend to focus on delivery of a couple applications. If you think of Facebook, it's really 2 or 3 applications. Some other cloud service providers provide more, but generally it's a handful of applications that are closely coupled with each other. Unsurprisingly, most of these guys start out in the cloud to host their business and their data. It's an easy platform to scale up or down, add resources, and it doesn't cost you anything up front. So if you're a startup, that's an easy way to go. But what we've seen talking to customers over time is that as most of these CSPs scale up and down, they tend to look at building their own data center. I mean, certainly that's what Facebook did. If you know of OCP, Facebook really built that. So that's just one example of them going out and doing it on their own, cloud service providers. The big reason they do it is they want to save money. And they see that as an easier way to do it than doing it on the cloud. So if you think about the cloud, some of the problems that the cloud typically has for cloud service providers is that most of these applications run across thousands or tens of thousands of servers. Their usage patterns can be bursty. Think about a news flash that comes out, and all of a sudden everybody's talking about it on Facebook or Twitter, or here's a new sale of some sort, and now guys like eBay have to support it, right? It can be very bursty. It can be very unpredictable. And that usually can be a problem for responsiveness for most of their customers. As you know, in this space, if your platform isn't responsive, that's a very good way to lose customers and reduce customer satisfaction. The other one's cost. If any of you have used cloud compute and storage, oftentimes it can be hard to predict exactly what your costs are going to be. It usually depends on factors that are out of your control, such as I/O rates or things like that. And then performance. Any of these applications, they're massively parallel, become very sensitive to things like network bottlenecks, migration of virtual machines, things like that. If you're in the cloud, your control over those factors is very limited. So that's why those are kind of 3 of the biggest reasons cloud service providers look at going to their own data centers to solve these issues. Now, granted, there's a lot of different cloud service provider types out there, and we'll talk a little bit more about that. But what this panel is about is talking about, okay, for CSPs that are looking to build their own data center, and most of them are going to look at NVMe or NVMe over Fabric, what are some of the things they want to think about to do that? And so with that, so what do they need in the data center? So one of the first things, obviously, is performance. They want performance that's predictable and consistent. They also want to be able to scale it relatively easily. Efficient implementations. Obviously, if a cloud service provider is doing this to save money, they want something that allows them to do that. OCP is one example of that. It's certainly not the only one. Density, right? If you think about where cloud service providers often have to put their data centers, and often they have to build multiple data centers, the real estate may not be cheap. Not everybody can build their own data center out in the middle of nowhere. So if you're building in a city or near an urban center, that real estate can be very expensive. So the higher the density of your solution, the lower your costs are from that perspective. And then finally, all these guys are looking to stay ahead of somebody else who does something similar. There's always competition for cloud service providers. So using cutting edge technology is certainly one of the ways they do it. And with that, let me turn it over to Josh Goldenhar of Lightpick Labs. Josh, I'm going to pass you control right now.
All right. Thanks very much, Mike. And hopefully everybody out there is staying safe and doing something interesting. And let's see if I can get this going here. So completely agree with the preface and premise that Mike has set up here. And we're very happy to be in this space where we actually have some cloud service provider customers. And basically they have the same problems as someone who's trying to do on-prem cloud. However, a lot of what they do has even more focus. They need even more efficiency, because at the end of the day, if they're investing into resources and they're not used, they've really thrown money away. It comes out on the balance sheet and affects them greatly. So what a lot of folks are saying that they want to do, especially if you're doing a high performance cloud offering, is you go ahead and take servers and you put local NVMe in them and you put it in every single server. This gives you the low latency and high bandwidth that Mike was talking about, as long as you don't exceed the size of a drive. And this is a real key concern here, especially for a service provider. They don't know what their clients are going to run on these hosts. So you don't want to do a 2 terabyte drive. That's these days probably way too small. But do you do a 4? Do you do an 8? Do you do a 30 terabyte drive? That probably can't be used. So you have to pick this size. And if you pick wrong, you're going to waste a ton. So most of these guys really suffer from very, very poor flash utilization, extremely low, which we'll talk about in the next slide. And then if the customer does want to share data, there's no ability to share. That is, if they're running modern applications that do their own data protection, that's okay. And it's all local to that system. But what if you have a more traditional application, or you have an application that needs to share data? Lastly, along those same lines, if you have a traditional database that's not doing its own replication and protection, how do you guarantee that that storage is protected? So all these are problems in these cloud service provider environments, simply because they don't always know what's going to be run. And when I said severe underutilization, you can see just kind of the comical correction here. Our normal customers who go ahead, normal doing on-prem cloud, for example, generally are about in the 20% capacity utilization range over their entire fleet. But we found cloud service providers are as low as 5%. And why? It goes back to what I said about putting a drive in every host. You put a drive in every host, you pick an 8 terabyte drive because that's the biggest you think might be needed. But in a lot of hosts, if you just happen to get the right mix, those drives are not used at all. So you've made a big investment in expensive NVMe flash into every host, and it's barely being used. Barely was actually the actual quote from especially one particular service provider we have that's deploying us in 28 data centers worldwide. So very, very low capacity utilization means they've made a tremendous capital investment, which is simply they're getting no return on. And then performance is also underutilized, which in this case is actually less of an issue. So what's the solution? Well, you take the drives out of the hosts. You go ahead and use top of rack, or actually distribute it across multiple racks. And you take this, and I'm getting a little bit of an issue here. You go ahead and move the drives out to LightOS target servers. You still get performance of logical volumes that's similar to a local NVMe, but now you have centralized storage. It's available to any application server that's on the regular TCP/IP network. So local performance, any size. These are thin provisioned, so you're actually only using the amount of flash that's written to. And this is perfect for service provider environments because it means you can over provision. If you know on average your customers only use about 20% of the storage that they actually request, well, you know you can over provision with thin provisioning. And if you get close to full, you can just add more drives, because we support scale up, adding more drives within a server, or you can scale out and expand the cluster. And this has a lot of other benefits there that can aid that. And what do you get when you use LightBits, LightOS? Well, you get very high bandwidth performance, very high IOPS at low latency, standard networking. So we're not asking you to change the way you manage your switches or do special settings for RDMA protocols. You still get rich data services. So you get data services similar to all-flash arrays, but at a much lower cost point. We can outperform traditional all-flash arrays by about 6 times to 10 times, yet be half the cost all in. So you get these rich data services, various configurations, as Mike was saying. If space is at a premium, you can go very compact. If performance is more important to you, you can optimize for that. If response time is more important, you can optimize for that. And also you can use QLC NAND, so you can use very inexpensive NAND, very inexpensive flash. And we can allow the use of that in ways that you could not use it locally. It looks a little bit like this. If you want to look at the piece parts, we are a software solution, although we do offer an appliance if you want to have it all ready to go. But otherwise, we are a complete software solution that you can put on basically any x86 target system with NVMe drives. Your application servers can be bare metal, or they can be Kubernetes or OpenStack. So regardless of the kind of environment for applications that you're using, odds are we are a fit for modern cloud service providers. And of course, SLAs have to be met. And we do meet the criteria for fault domains. So this is very common. You want to go ahead and, for instance, have an entire rack be able to fail and have your storage stay up. And so LightOS does have this notion of failure domains. You can see a deployment here where you can think of these as 3 different racks. And with our backend replication, if you have defined your domains here as A, B, and C, which is really like rack A, rack B, rack C, and we do either our 2x or 3x configurable replication, we'll make sure to split those replicas across the targets in different racks. Thus, you can have an entire rack go down and your logical volumes will stay up. And of course, you don't have to split by rack. You can split by power zone or even by row because it is TCP/IP, 100% routable. This can be anywhere in your local data center. I did mention QLC, so I want to make sure you understand that we treat flash, regardless of the flash type, we treat flash the way it likes to be treated. That is, we take random IO in, we reorder it, and we sequentialize it, and we play it out or write it out to the actual NAND media in large blocks, and we write it out sequentially. So we actually end up getting higher levels of random performance than the drives are rated for, because we're converting random IO to sequential IO. And because we write sequentially in large blocks, for instance, on QLC, we can get up to 5 times the rated endurance of the drive. That is, if the drive is rated for only 0.17 or 0.2 drive writes per day in random write mode, we can get nearly 1 drive write per day out of that if you use our technology on top. So you can extend the life of QLC, which means you can use QLC in places you thought you couldn't use it before. And this really lowers cost, yet it doesn't degrade the service. So it enables cloud service providers to go ahead and keep their SLAs for their customers. And lastly, it integrates in all sorts of different ecosystem parts. So we are just on Ethernet, TCP/IP networking, no special cards, no special switch settings needed. We are managed with a CLI and a RESTful API, as well as plugins for different environments. So CSI for Kubernetes and a Cinder driver for OpenStack. And really can integrate into almost any provisioning environment, all in an automated fashion. And then for monitoring, you do have plugins for Prometheus, for telemetry, and then we supply a pre-configured Grafana, but you could also hook into the monitoring system of your choice. So it's really made to integrate into any kind of modern automated infrastructure. So in summary, for CSPs, we're software defined, which is great. You bring the hardware. Optimize the hardware for your environment, and we'll bring the software and give you a storage solution that performs better than traditional all-flash arrays at around half the cost. You do support thin provisioning, compression per volume. Data protection levels are set also per volume. We protect against drive failures inside each box. We increase the endurance of flash, that is letting you use QLC. TCP/IP infrastructure, all on standard NICs, and no proprietary drivers. We are based on NVMe over TCP, so we're 100% standard, and this is available in any modern Linux distribution. And the targets are also failover, supporting multipath. both on a network link basis as well as a target server basis. And that's what we do, really, to help CSPs get the most out of their storage, save money, and provide the best service to their customers.
Thank you very much, Josh. Next will be Joel Dedrick. Joel is, let's see, let me give Joel control here. Okay, Joel is VP and GM at Kioxia. Go ahead, Joel, take it away.
Thank you. Thanks, Mike. So I want to start by defining terms. Mike uses the term CSP, Cloud Service Provider, to mean someone who is providing a service to their customers using cloud resources. That's not the only definition of CSP. In fact, I think maybe at least as common usage would be to call public cloud providers CSPs. So I've listed here kind of three flavors of what you might call cloud service providers. The first are infrastructure providers like Amazon, Google Cloud Platform, and Azure. Those are the public cloud, kind of tier one public cloud providers. Then there are the kind of cloud providers that Mike mentioned, which we call SaaS companies, B2B, like Salesforce and ServiceNow, or B2C like eBay and Uber and TikTok and whatever else. I'm going to focus a little bit on the first category. The big three public cloud providers don't need help from certainly anybody on this call. We sell them billions of dollars worth of flash, but beyond that, they write pretty much every line of software that runs under their roof. However, there are a large number of companies trying to compete with these three providers, and they don't have the level of resources that would allow them to write all of their infrastructure code. And so they are, part of the center of the bullseye, essentially, for Kumoscale and others. And so I'm going to talk really a little bit about what those customers need from us and how NVMe over Fabrics can help them, and actually where it falls short of what they need. So let's zoom in on Google Cloud Platform just for a moment. What sort of storage offerings can you get from Google, and therefore what would you need to provide if you want to compete against them? The Google zonal or regional SSD is replicated across availability zones or regions. It can do about 100,000 IOPS and about 1,200 megabytes per second per instance. That is per compute node. So this is not quite full local NVMe performance, but it's certainly well in excess of what most application instances can consume. By default, there are two replicas, and this costs about $340 per terabyte per month. There's a rule of thumb that has worked remarkably well for a long time, and that is the price at which you can rent storage from a cloud service provider per month is about the price that you could buy that media quantity one on Amazon. So it's actually a fairly profitable business, but nonetheless, there isn't a lot of room in the price for expensive software. Certainly, if you're going to compete against someone that writes all their own code, paying a lot of money for software to manage your storage isn't in the picture. But in addition to block storage, importantly, they offer distributed file system and a distributed object store. And both of those are shareable, importantly. So many applications need to share data across instances, and simple local block storage, as is offered by most NVMe over Fabrics providers, is a tiny part of the real picture. So those three abstractions are really needed. And in addition, there will of course be several database services built on top of those. So what does it take to compete? If you're going to offer services that compete somehow against Google Cloud Platform, what do you need to do? Well, first, commodity hardware. Enterprise storage arrays are built with a very high degree of internal redundancy and involve custom hardware that makes a lot of sense at small scale, but stops making sense at the kind of scale that you need to compete with the public cloud providers. They need cross availability zone data protection, of course. The expectation is that data is never lost and remains available even in the event of fairly major outages. And here's the important thing: multiple abstractions. Block storage isn't enough. We need shared file storage. We need object storage. And you know, going forward, there will be queues and pub sub databases and other abstractions. And you know, interestingly enough, as we've served this class of customer, what we found is that while CapEx efficiency is certainly important, another kind of efficiency matters just as much, and that's people efficiency. The size of the teams that are assigned to manage storage in these companies don't number in the hundreds of people. They don't have armies of SREs dedicated to the care and feeding of each different storage abstraction. A relatively speaking small number of engineers need to keep this up and running. And so management efficiency and the degree to which you can automate multiple abstractions on the same infrastructure ends up mattering almost as much as being cost effective. Cost matters, of course, and the bigger the scale, the more it matters. And so the software cost has to be a lot less than the cost of the flash it's managing. That's pretty fundamental. Open source is great. If it's not open source, it needs to be very inexpensive. And then finally, of course, the table stakes are performance comparable to local NVMe flash, which if you're going to do network storage means NVMe over fabrics. So how does CumoScale answer these challenges? We have made a couple of very important announcements Tuesday of this week, actually. Our architecture continues to evolve at an exploding pace. We have now embraced Kubernetes as a sort of unifying concept for our management plane. So if you look at the lower right corner of this picture, we picked 3 CumoScale storage nodes. CumoScale storage nodes now are also Kubernetes worker nodes. And we choose 3 of them to become the masters of the cluster. And so they are running the Kubernetes master runtime. I want to emphasize that this doesn't mean we're serving storage to a Kubernetes cluster, although certainly we do. It means we're using a private, small, kind of micro level Kubernetes cluster to manage our own resources. And this is sort of independent of the consumer of the storage. Internal to the CumoScale system, Kubernetes is now the management infrastructure. And so there are 3 nodes that are dedicated to running our management services, which are now all containerized. And as you can see in the blow up there in the inset, the CumoScale provisioner, telemetry database, a bunch of other functions are all running on all 3 of those nodes. The remainder of the storage nodes shown on the left are also Kubernetes workers. And so in addition to providing networked high performance block storage, we can now provide object storage, a shared file system, and importantly, those functions can be provided with local NVMe volumes that are managed as CumoScale virtual volumes. So they get all of the thin provisioning and efficiency that we've discussed. But they don't require a network hop to reach the object store or the file system. And so they run as fast as if those applications were running on bare metal. And so now you can provide multiple storage abstractions, all managed in a single infrastructure, all benefiting from the storage services that run on CumoScale and the management visibility and flexibility and automation capability that CumoScale provides. So this becomes now really a service provider in a box. This system has grown from being a high performance block system to a multi-abstraction, full service cloud storage infrastructure, all under one control construct. So that's the end of my my time, and I'll look forward to answering questions at the end.
Thank you very much, Joel. Grab control here.
Control, there you go.
I got it. Okay, perfect. And next we have Mark Micklin. Mark is Director of Platforms Partner Alliances at Western Digital. Go ahead, Mark.
Thanks, Mike. Next slide, please. Thank you. I just wanted to review a little bit, sort of the essence of NVMe. It was created to provide a consistently low latency and a predictable latency for storage. This is something that prior interfaces had not really been able to do. It also was created to run on PCI, which gives you the advantage of using the ever-increasing PCI bus speed. So we've gone from Gen 1 all the way up to people are starting to work on Gen 5 now, with the performance doubling at every step. And servers have really done a lot to take advantage of this. So in many servers today, you get a lot of PCI lanes, and those lanes can be routed to NVMe slots or NVMe devices in the front of those servers. So all good stuff. A lot of our transactional workloads that we've done in data centers run on NVMe today and take advantage of this. And we've seen extremely high performance gains over certainly spinning media and SAS and things like that. Where NVMe starts to run into problems is when you want to take it outside of that server. It's meant to be an in-the-box type interface. Some people have expanded it beyond that, but it really doesn't scale very far. And so that's where NVMe over Fabric comes in. And NVMe over Fabric gives you all those same benefits of NVMe devices, the NVMe command set, the low and predictable latency, but gives you the additional advantages that you get from a storage fabric, which include disaggregation. You can get your storage away from your compute and scale them independently. The shared access, which Josh talked about as well, and eliminate some of these PCI limitations. So PCI has limits on the number of devices you can directly address and things like that. So it gives you the opportunity to go well beyond those limits. And I'll show some examples of that in the next slide, if you want to go on, Mike. So now I want to talk about a couple of different ways that you can implement NVMe over Fabric. And what I'm showing here is a traditional server-based architecture. So you have a CPU and its local memory and a PCI bus in there. You can have flash connected to that PCI bus, and that would be the typical NVMe implementation. And what you'll see today are appliances that combine that flash with a high-speed NIC in that NIC slot, and they can provide NVMe over Fabric in that way. And so essentially your data would be on the flash. If you wanted to read it from a remote device across the fabric, that read would go through the PCI bus into the CPU's memory, and then another read from the CPU memory out through the NIC and out over the fabric, and you deploy NVMe over Fabric in that way. I like to call this, using x86 CPUs or the Intel architecture to host NVMe namespaces. And it's quite easy actually to really consume your entire server with it just running NVMe and NVMe over Fabric in this way. People like to think that they're going to run a couple of applications on the same machine that they're hosting their NVMe over Fabric, and pretty soon you have a big bottleneck in that server. And so what this results in is a situation where your capacity likely outweighs your performance. So I'm showing a very typical 2U24 chassis on the right there. If you load that thing with 24 NVMe SSDs, you're not going to be able to utilize all of the performance that those SSDs can provide, because you're going to run into bottlenecks elsewhere in the system. So you'll have a high capacity box, but not necessarily the maximum performance that all those SSDs can provide for you. Another problem with this approach is that your PCI infrastructure and the speed of the individual SSDs is very much tied to the CPU roadmap. And so what I mean by this is, we're moving to Gen 4 today. AMD has it out, Intel's coming. In a few years, there'll be another move to Gen 5. And so if you're thinking about a server with 24 SSDs in the front, you're probably going to want to change that server based on what PCI interface and what CPU speed and core count and all that kind of thing that you want to have in that box. But that's a lot of money that you're moving, or more than likely, you're discarding those old SSDs and getting new. And then the last bullet here, I think some of it kind of got cut off, but most cloud service providers will qualify a set number of servers that they're going to allow into their data center. And then they're going to do a best fit. They're going to apply the best fitting server to whatever application comes along that they need to host or they need to run. And it's never ideal. And so when you're using servers to host NVMe over Fabric, you're kind of locked into some of those decisions that might have been made a long time ago and not able to actually pick the best server. That's okay, Mike, if you want to go forward one. And one more, please. There, perfect. So what we're advocating is what I'm calling fabric attached device. So in some ways, the architecture looks very similar to what's on the left, but you'll notice that the PCI bus may be embedded in each of these devices, but is not the fabric that interconnects them. So in this case, Western Digital is in the business of selling storage, so we're focused on flash and disk, but we have partners that are focused on these other devices. But once you connect all of those devices over a fabric, and in this case, I'm choosing Ethernet, and using NVMe over Fabric to move your data around, you get rid of a lot of these limitations. And so, Mike, if you can do one more build, please. So the benefits here, first of all, I'm not using my compute or my server infrastructure to host NVMe namespaces. So in this case, my flash device can put an NVMe namespace out over the fabric. Anybody that has the proper access rights can mount that namespace, can come in over the control plane and create new namespaces, can run data protection, whatever you want to do with that flash. And I'm not using my valuable CPU cycles and my processing power in my compute device to do that. So that's a key advantage of this type of network is essentially we're not consuming a server just to provide NVMe services or resources to everybody else on the fabric. Once we're disaggregated, you can really optimize your scaling. So in the case of flash, when you want to add flash to your infrastructure, you don't have to add a whole server just to do that. You can add our flash devices or our flash JBOF directly onto the fabric, and that capacity is realized by every other resource that's available on the fabric as well. So this whole problem of getting tied up into, what gen server am I going to deploy or what server type am I going to deploy, it just isn't there anymore. So this gives you a lot of flexibility in that sense. You can upgrade or expand your flash when you need to, or when there's, going from TLC to QLC would be a good example as well. You can choose to do that, and you're not tied to any server architecture to necessarily deploy it. And then we have done a lot of work to performance match our flash devices to the fabric port. So in our case, we're using 100 gigabit Ethernet, NVMe over Fabrics, and the amount of flash that we have in each of these products I'm showing in the bottom are geared to provide that full 100 megabit capacity. So 12 gigabytes per second in either direction out of any port on any of these boxes is exactly what we're offering. And so you don't get into the situation where you have maybe more capacity than you have performance, like you might on the left-hand side. And then because of this, so when you add all these things together, and particularly the fact that we're not using an x86 architecture and DRAM and things like that that are in a server to provide these namespaces over the fabric, you get the highest density and the lowest power out of these solutions of anything available. So just a quick product pitch. We've branded these all as OpenFlex. We have the F3200, which is a really dense flash attached or fabric attached flash device with 100 gigabit Ethernet port in the back, and then a more traditional 2U24. Again, not a server base. This is just a more like a JBOF, but NVMe over Fabric and Ethernet ports in the back. So Mike, that's all I had.
Thank you very much, Mark. All right, let's go to the panel questions and the audience surveys. Our first panel question is there are a lot of factors that drive whether CSP's compute and storage infrastructure should be cloud-based, on-premises, or both. When should a CSP start thinking about this question? I'll start with Josh, and then we'll go to Joel, and then finally we'll finish up with Mark.
Josh has just got to find the unmute button. This is actually something that our customers struggle with every day, and there's no clear-cut answer, to tell you the truth, on some of this. So whether or not I think a cloud service provider's compute and storage infrastructure, I think by definition is cloud-based. If you're talking about the customers, the on-premise part a lot depends on their expectation of performance. So for example, in almost all the cloud service providers today, the big ones, the Amazons, Microsoft Azure, Google, et cetera, if you put NVMe performance, you essentially can use servers that have local NVMe. They have instances, and that's it. That's your choice. So you don't get any kind of redundancy. You can't share those devices. You can only use modern cloud native applications that do their own redundancy. It's not actually terribly expensive, but you're running DAS in the cloud, and you break a lot of the philosophy of a lot of these applications, because now they're tied to certain physical hardware, and the whole idea of the cloud is that all your applications are portable. So a lot of it is based on that. Is what kind of performance do you need? Do you need to share? Is it important for you to go ahead and get much higher utilization? So by moving that on premises, you generally get much better performance. As was kind of noted, I think by Joel, you're paying an awful lot of money for that storage in the cloud. So you can buy on-premise storage that performs much better than in the cloud for probably the same or much lower cost than a one-year subscription. So there's all sorts of reasons there, but I would generally say it's around performance, and then very smaller items are around privacy on the data, and then finally charges of moving your data in between cloud and on-prem.
Yeah, that's a good point on the privacy issue. Certainly in a lot of countries, they require data to be resident. If it's got private information or personal identifiable information, they're required to be resident in their country. So that's a great point. Joel, what do you think on this one? What have you guys seen?
I think this is all about scale. I mean, public cloud providers, all of them are kind of have the Hotel California billing plan. You can get your data in very inexpensively, but getting it out costs a lot of money. And so in our experience, you're either all in on using public cloud to deliver your service, or once you decide to build your own infrastructure, it's very rare to go halfway, because moving data back and forth is so expensive that it consumes all the advantages. And it comes down to, do you have enough scale that the cost of the engineering talent to maintain your infrastructure is less than the benefit of having it on-prem? If your infrastructure needs are growing 10% a year, then for every few thousand machines or so, you can afford one engineer to lower that growth rate by half to 5%. So rough order of magnitude, every several thousand machines, if you're growing, you can afford one engineer whose job it is to be more efficient. And so, if it takes a team of 20, you're looking at 50,000 compute nodes before it makes sense to run your own infrastructure. And so, and not surprisingly, that's the scale, that's kind of the bottom end of the scale of the cloud service providers that do that. Storage is a little different than compute. If we were just looking at compute power, using the public cloud is a pretty good deal, because there are very few compute applications other than machine learning or something that run 24/7 at a constant load. And if you can turn the billing off when the need goes down, that's a great thing. But storage is different, right? Once you store something, you expect it to stay stored. And so the meter runs 24 hours a day. And it's usually storage that causes people first to decide, I'm going to stop sending millions of dollars a month to Amazon, and I'm going to build my own infrastructure. But it's really all about scale. It's how many engineers is it going to take me to manage block, and how many to manage file, and how many to manage object, and how many to manage database, and does that number of engineers make sense given the amount of money I'll save?
Perfect. And Mark, what are you guys seeing in Western Digital on this?
I was going to say, you should always be thinking about that question, and you probably have been thinking about that question. And my encouragement is to never stop. And all of our demands, demands on all of us are constantly changing, right? COVID is a great example. There's a lot of companies that are running completely different operational models now than they were a year ago. And nobody foresaw that, right? And so you always need to look at these options and figure out what's the best at the current point in time. A good example, we talked to a customer just this week, actually, that was spending, I think it was in mid 400,000 a month at a cloud service provider. Company got a new CEO, right? So new CEO comes in, starts wanting to press into everything. Why this? Why that? Why do we do it this way? And one of the questions came around to, well, why are we using cloud service versus on-prem? And they hadn't looked at that decision since they made it a couple of years ago to go to a cloud service provider. And when they actually did the analysis and figured out, hey, if we brought stuff on-prem, they got their monthly run rate down to around 70K. So you think about that, I mean, that's a couple $1,000,000 a year difference in OpEx, just because they hadn't looked back since they made a decision to take certain things to cloud. And now you're forced with, looking stupid in front of the new CEO. So the recommendation is just always be evaluating your options.
I think that's a great point. And with that, let's go to the next, the first audience survey question. I'll launch this, and while we go ahead and answer that, we'll go ahead with the next panel question. This question is, what is your organization's greatest concern when using cloud computing and storage? And we'll give everybody a couple of minutes to answer that. And with that, let's go to the second panel question. That panel question is, what are some of the biggest hurdles or traps that CSPs should look for when considering implementing their own data center infrastructure? Kind of the reverse of the question we just asked, but if there's best practices, things like that, that'd be great. We'll start, Josh, with you, then go to Joel, and then we'll hit Mark again. Thank you.
I was not ready to go first again. So when you're implementing your own data center infrastructure, one of the things is actually something that was touched on, I think, by Joel. You have to look at, can you afford to hire enough developers to do what you want to do? So writing your own storage layer, because as was also mentioned, when you store something, it's expected to be there when you go to retrieve it. So writing a reliable, scalable, dynamic storage layer is a big task. And of course, we believe that you shouldn't do that task. Don't go develop it yourself. We have professionals who have developed our product, BlightOS, and rather than implement it yourself, you should go ahead and use a product like ours. It's standards-based, it's scalable, it's very high performance. We've done the work for you so that you can concentrate on your infrastructure, your provisioning environment, the things that actually you can sell, rather than what's underneath. It's kind of like if you go to buy a car, do you want to make your own tires? Do you want to make your own seats? These are things that are available. It's way easier if you just use what's out there. And so that's one of the biggest things is if you're going to implement your own, you really have to think about what it's going to cost you to develop versus just purchasing something off the shelf, which is an integration task.
Very good point. Joel, I know you touched on some of these things earlier, the people one being the biggest one. Are there any other things that you guys saw that they're critical when people are looking at implementing their own?
Yeah, I think one aspect that doesn't have a snappy name, but it's a way to think about these products that goes to the question of how many people will it take to manage them, and can I find those people, is their automation structure. We have never run into a customer that can use the plain vanilla right out of the box set of capabilities that we offer. Everybody needs something somewhat different, and everyone has work processes and unique aspects of their business or their customers that aren't like anyone else's. And so you have this sort of curious situation where we want to provide as complete a solution as we can, And yet, by definition, we can't do the entire job. We need to provide a platform on which a minimum number of customer SREs can automate their unique business processes. And so look at the system and say, what does your automation platform look like? How easy is it for me to automate the things that are unique to my business without having to invent things that aren't unique to my business? That's kind of the line that we want to try to draw perfectly. And it's it's an art as much as a science. It's an architectural art.
Excellent. And Mark, what have you guys seen in this area? Obviously, not looking at when you should do it is certainly one of the traps, but once you get there, what are some of the other things that you guys have seen with your customers?
Yeah, we see people get kind of locked into some rigid infrastructure or rigid architectures. So one of the points I mentioned in my slides was what's very typical is to see people have selected, 1 or 3 or 7 or, some relatively small number of qualified servers or server types that they'll bring into their data center. And then they try to map every new workload onto one of those server types. And so that pretty much always generates a compromise, right? You're not optimal for that application. You're optimizing around the safety of that proven server type. So, it's understandable that you would do that, but on the other hand, you're not being flexible, and at some point that may bite you as well. And so I think just be flexible, and that could be a server type. It could be another one I run into a lot since we're promoting NVMe over Fabric, and we've chosen Ethernet as our fabric. There are other, more long-standing and known storage fabrics, right? Fiber channel most often comes up, where people have just a ton of money dumped into a fiber channel infrastructure, and then they're going Ethernet. Why would I want to do Ethernet? And we can show them the advantages in latency and performance, but then, okay, well, there's all this stuff I got to redo or undo to be able to use Ethernet. And so there's hesitancy there. And so you're missing out on some really huge benefits because of an infrastructure choice that you've made, maybe 10 or 15 years ago.
Excellent point. Okay, let's go to the second audience survey question. And that question is, when looking at building your own data center, what is your greatest concern? This is also select one. I'll launch this, give you a couple of minutes to fill it out. And with that, let's go to panel question number 3. This time we'll start out with Joel from Kioxia, then go to Western Digital, and Josh, you can go last this time. But that question is, NVMe and NVMe over Fabric have helped accelerate a variety of applications. How can CSPs utilize these technologies to accelerate their application offerings? Go ahead, Joel.
That's a very general question. Let's see. One dichotomy that we see is between 2 broad categories of applications. There are, and these differ by the implicit contract between the compute piece and the storage piece. In the legacy, any time before 5 to 10 years ago, say, storage was implicitly reliable. If I write something to storage and I get an acknowledge, the implicit contract is that piece of data will never go away unexpectedly. It'll be available forever. And so storage infrastructure had to be built to meet that SLA. When you reach cloud scale, that the expense of meeting that SLA becomes unbearable, and you have to start to say, okay, everything fails. Let's just architect around everything, including storage, eventually will fail. And so let's design for that. And so we see databases that were built in the last 10 years ago, last 10 years or so, do replication at the database layer, right? So Cassandra and the clones of Cassandra and all those have multiple copies of each data element that are not provided by the storage layer. They're provided by the software itself. And so in the real world, you have to support both. And so you need to be able to flexibly, on an application by application basis, use the performance of NVMe over Fabrics to make the application run fast, but also emulate legacy storage, meaning meet the meet the availability guarantee when necessary, but not impose the cost of meeting it when it's not necessary. And so in reality, we have to have one foot in both camps. We have to support legacy applications that need reliable storage, even while running on unreliable hardware. And we have to cost effectively support applications that don't care if storage fails. And so that's one thing to look for when you're looking for a technology. If you don't have software in the path, if you're running raw drives on your network, then who's responsible for the failure of a drive when the application doesn't take care, the application of the database doesn't take care of that failure? It's something to think about.
And Mark, what have you guys seen as kind of some of the applications that really have been helped with NVMe or NVMe over Fabric?
Yeah,
Is
both
there a particular group that you see?
Yeah, for sure. NVMe and by extension NVMe over Fabric are both very good at anything transactional. The IOPS and the consistent latency on those IOPS makes a huge difference in transactional applications. So the most notable things that come to mind are any database, right? Any database where you're doing read modify writes and stuff. NVMe is very good at that, and so is NVMe over Fabric. But also things like indexing. We're running a Splunk indexer on NVMe over Fabric, and so we get the scale of having a huge, we can have as many, we're basically unlimited on how many indexes we have, and the IOs per second and the latency to get to them is just outstanding. So any transactional workload is where I would start.
Excellent. And Josh, what have you guys seen at Lightbits? And obviously NVMe-oF is big in your space, right?
Yep, very much the same. I think if you combine a couple of things that were said by my other panelists, you get a picture. And that is, yes, modern scalable database apps are made to protect themselves. However, in talking to Wall Street customers, they'll tell us that, well, yeah, we have a need to deploy Cassandra or Mongo or Couchbase, et cetera. But at the same time, we have 6,000 legacy apps that we can't port, and they expect when data is written, it's reliable. They expect to be writing basically to an all-flash array, maybe on Fiber Channel. So the nice thing about NVMe over Fabrics, NVMe over TCP, is it lets you use Ethernet. It lets you use TCP/IP, which is ubiquitous, so you don't have to do anything special. The port cost is anywhere from half to a third if you're considering new Fiber Channel 64 or 128. And you get the same or better bandwidth, the same or better latency. So your per port cost is way, way lower. But once you actually have multipath via asymmetric namespace access in your head and you're thinking about this, these things are very, very similar. So you can take these legacy applications and run them on this very new infrastructure, but the application doesn't have to make, the classic application does not have to make any changes. And so that's really powerful. You can accelerate, as was also said, anything transactional and move over, and it doesn't necessarily know that it's not running on Fiber Channel anymore. It's running on Ethernet and NVMe over Fabrics, and it's just happy as a clam, and you're accelerating your performance because there's not a bottleneck for storage, and you're probably using newer processors and stuff that are also faster.
Very good. Let's go to the audience Q&A right now. So the first question we have, and I assume this is to Lightbits Labs, is: are you similar to Vast Data?
No, we're much better than Vast Data. So it's no. That's a shout out to some of my friends at Vast Data. So to be clear, NVMe over Fabric, and so I think for all the folks on this call, is a block protocol. So we're talking about block storage. Vast is an NFS service. It's a greatly improved and a scalable NFS product, but it is still a file system NFS product. So we're talking about things that are going to give you latencies in the sub 1 millisecond for sure, but probably in the sub 500, sub 300, depending on whose claim, sub 200 microseconds. So we're talking about performance for block that's at for 4K that's at the same level as local drives, better than SATA and SAS drives, and on par with local NVMe. So this block storage, light bits in particular, can make use of Optane media. We do, in a similar way, allow you to use QLC. So you can use QLC on the back end to keep your storage costs low. So in those ways, you could claim that we're similar, but we're vastly different, pun intended, because they are a file system offering and we are offering block, in which you can put your choice of file system, the one that makes sense for you, on top of us.
Very good. Next question we had, and we'll let, this one is also to Lightbits, and it's how does Lightbits Target connect to Windows clients?
So the honest answer is not terribly well. Microsoft has not adopted any NVMe over Fabric driver. There is an independent one for NVMe over Fabric RDMA, but for NVMe over TCP, there is no driver. So Microsoft as a whole does not support NVMe over Fabrics for Windows. Now, if you are running Windows inside a virtualization environment, such as OpenStack, then you can go ahead and provision your storage from NVMe over TCP to the OpenStack hypervisor, and the hypervisor in turn can go ahead and offer that storage to basically any OS you're running underneath the covers. So if you're running in that kind of environment, you can run directly. But if you were directly running Windows on bare metal, you would have to use some kind of gateway to do any kind of NVMe over Fabric, because Microsoft doesn't have a driver there.
Got it. Okay, and the last question, this one is to Mark, and that is, what target software runs on the OpenFlex? Does it support NVMe over TCP?
Yeah, so on the target software question, the good news is anything. And so, I'm not joking about that. What we've seen is that the NVMe over Fabric driver is really good. So any Unix, Linux that has NVMe over Fabric support, we will run any application that runs on that Linux. Any software-defined storage. We do prove them out. We do proof of concepts every day where we run through the checks and make sure. But the only places where we've seen any problem with OpenFlex and NVMe over Fabric, or in any application for that matter, is there are some software-defined storage products that actually implement Linux on their own. So rather than installing on top of Linux, they embed it. And then if they haven't done a good job of including the NVMe over Fabric driver, or maybe they haven't even tried to include the NVMe over Fabric driver, then we have an issue. But everything else, which is 98, 99% of what's out there, runs just fine. TCP support is on our roadmap. We don't ship it today, but we'll be bringing that to market in the next, hopefully near term. I'll say within 12 months, but we're working on it.
Very good. Let's see, we had a follow-up question. That question is, does OpenFlex support Windows Server clients? I imagine the answer is pretty similar. Since
yeah, same answer
Windows, right?
to Lightbits. So Windows, Microsoft does not have NVMe over Fabric support in Windows Server. So natively, no. There is a third-party driver out there. We've actually done a lot of testing with them. It's pretty good. It works well. And I guess I won't do a commercial for them, but I'll do it this way. They are getting involved in supporting the University of New Hampshire's interoperability lab efforts with NVMe over Fabric testing. And so if you want to see that driver, see who's got it, even test it, get a hold of UNH, and you can go from there.
Perfect. And with that, I think we've hit all the questions. Again, thanks everybody for joining us. We will send out a link to the recording of this webinar, which will be hosted on the G2M Research YouTube channel. That should go out by the end of the day tomorrow, as well as a PDF of the slide set to everybody that's registered. Thanks again to our panelists, Joel, Josh, and Mark. I think you've had some great insights in here, and I hope everybody has a great day.
Thanks, Mike.
Thanks, Mike.
Thank you.
Thanks, Mike. Take care, all.